So that will tell you where the slope is 0. Okay. In addition, if the slope is undefined or the function is undefined at that point, that's also a critical number. Okay. Any question with that? Somebody.
Can you go back up for a second?
What's that?
I was trying to copy the definition. Can you go back up?
Yeah. Somebody's sending me messages. What's the message? Is it a private message? Can't see. So guys, what I'm going to start doing is just dropping you out from my lectures if I don't see your camera on. We've had over
Aziz said that his camera's still not working.
Tough luck. I am going to drop you guys out if your camera is not working by now. We're 8 weeks into this semester. You can't get your cameras to be working? Come on.
I informed you last week that my phone fell in the water, so the camera is not functioning.
Okay, you guys have until Wednesday, Thursday to get your stuff together, okay? So please, Mr. Hasib, get it working by Thursday for lesson. You need your camera on for the exam anyway, so there's no choice about that. Okay, so that's your critical number, right? So you need to understand what a critical number is, class. So by taking the first derivative and setting equal to 0, you will find your critical number, okay? Now, Rolle's theorem, okay, is saying that, so for Rolle's theorem, it's saying that if you have a function, so let's have some function here. Let's say this function, okay? And it's in a closed interval. So let's look at this interval here, AB. Let's look at this interval. So here's a closed interval AB, okay? And if we go back up, so f is continuous. Obviously, the function is continuous, right? If you trace it, there's no break in the function. So the function is continuous. And it's differentiable on an open interval. So on this interval here, on this open interval, a comma b, right? The function is differentiable. And the reason they said open is because it may not be differentiable at the end point. So that's why we say on an open interval. And if f of a is equal to f of b, so what does that mean? It means that if this is the function f of x, okay, if f of a is the same as f of b, that means if this was the y-axis, let's just put a y-axis here, okay? If this height is the same as this height here, so this is f of a equal to f of b. Does that make sense so far? Then it's guaranteed that there is at least one c in the open interval where the slope is 0. So obviously from this picture that I'm showing you here, the slope here is 0, right? It's a horizontal line. So anytime this happens where f of a is equal to f of b, it is guaranteed from Rolle's theorem that there is a slope of 0 in that interval. And you can pick many functions if you want, right? Think of any function. Now, here's a case that I want you to explain to me. Why this is not the case for this function. And if you know the answer, keep it to yourself, okay? Keep it to yourself. I'm gonna ask for volunteers. So let's say this is A, and here is B. This is the function g of x. So obviously g of A, okay, And this same point is going to be g of b also, right? So please tell me why this is not true. Rolle's theorem doesn't work here. Why? Miss Vardy. Yes, Yang Yang. I didn't say to blurt out the answer to everybody, Yang Yang. Miss Vardy,
Yes, Professor.
why is Rolle's theorem not satisfied here?
It's because it's not a critical point.
Well, there is a critical point. There is a critical point. This is a critical point right here. Critical point is where the slope is 0 or it's not differentiable. Miss Zapata,
Yes.
you have an answer for me?
No.
Speak up, please. Can't hear you.
I do not.
Okay, Miss Perez. Miss Perez?
Yeah, I don't know.
Oh, no. Okay. Does anyone know the answer other than Yang Yang?
I mean, you basically, from my understanding, said that this function is not differentiable because it's not in an open interval. Doesn't have an open interval, no?
Well, it is. Well, let's go through the definition, right? Is
Mhm.
this function continuous? Yes or no? Look
I
at
don't
the
think it
function.
is.
What
It
do you
is.
mean you don't think it is? You say you don't think it is, or it is?
It's not, because the curve is not smooth. He has like bound up and down, no?
Man, come on. When someone talk of continuous, guys, what you're doing is taking your pen and trace the function. Can you get from the left side to the right
Yeah, I
side
can.
without raising up my pen? Yes or no?
Mhm.
Continuous is just, you know, a common sense visual thing, right? Obviously, if my function was like this, then it's not continuous because you can't get from here to here without raising up your pen. Okay? You can't do that. So this function is continuous, okay? Now, so it is on a closed interval. So here is a closed interval. We're saying that this interval is closed, right? And the interval closed. And then differentiable on the open interval. So here is the closed interval. We're only concentrating on this interval here, right? Is the function differentiable at every single point on that red line? Yes or no? Yes or no? You guys ready for your exam on Thursday? I mean, this is exam questions. Ms. Carr,
No, it's not.
why not?
Because the critical point, the slope there is not 0.
Right, the slope here obviously is undefined. On one side, you're gonna get one slope. Here, m is different from here, right? So this function is not a differentiable at that point. Where that block dot is, this function is not differentiable here. So that is why Rolle's theorem cannot be applied for this graph. The function must be differentiable at every single point. Questions on that?
Can you just repeat like the definition of what makes things differentiable so I can copy this down really quick?
For a function to be differentiable, right? The limit at every single, well, first of all, it has to be continuous. Okay. And then the function must be defined at every point. Obviously, if it's continuous, it is defined at every point. And you can even think, remember, the definition of the derivative is really a limit statement, right? So basically the limit from the left has to be the same as the limit from the right. Okay. So if you pick a point, look at this graph here. Let's say I pick this point here. Let's just pick a number, 4. X equals 4, right? Is the limit from the left the same as the limit from the right? Yes or no? Yes, it is. But if you go to this point here now, if you go to this point here, let's say that's 2. The limit from the left is not going to be the same as the limit from the right, because the limit here, right, is going to be, or the slope is going to be some positive value, and the slope here is going to be some negative value. Because remember, the derivative tells the slope. Okay, derivative tells you the slope. So that's where we get the little problem. Questions on that? Any questions? Okay. So let's look at an example. So let's say I give you, so given f of x is equal to x squared minus 8x plus 5 on the closed interval, two comma 6. Okay. Determine whether Rolle's theorem can be applied to f of x.
Is that 2 and 6?
Yes. I don't know why my pen. On the closed, is can be applied to f of x on the interval. And then if it can be applied, okay, find the value or values in the open interval AB. So go through the definition and check, see if this can be done. Please try it. Daniel, what do you think? Can't hear you, Daniel. You're on mute.
No, no, I know I graphed it. I think it applies, no?
So what's the first thing you should do, Daniel? Look at the
I did
definition.
I graphed the
F
function
be
first.
continuous, right?
And it's continuous, yeah.
The closed interval. So
So
is
we have
this-
like a function.
is this function continuous? Yes or no?
Yes.
Why do you say so?
Uh, I pass on that.
Ms. Maciel, is that function continuous? Yes or no? Ms. Dalma,
I'm not sure.
is this function continuous? Yes or no?
Isn't it continuous because there's a closed interval?
That's not the answer, but the answer what you give me is correct, but that's not the answer I'm looking for.
Or you're talking about the function like by itself?
Yes,
Oh. Because isn't it a parabola?
no, you're close. It's not a, it is a parabola, but it begins with a P. The answer I'm looking for begins with a P. Miss Dennis, do you want to help Miss Dalma?
I have to get the door. My bell just rang. Sorry.
Jonathan,
Yeah, I'm not sure how to begin. I know it's continuous and I'm just not sure, I'm waiting to hear somebody else say it.
Tony Zhang. No,
No, Professor, I have no idea. Like, I know it is a parabola, but like, I don't know what are you looking for? Like,
Carl,
I'm not sure.
I'm not sure.
Miss Rodriguez.
Not sure.
Oh my gosh, Junior, what kind of a function is x squared minus 8x plus 5, class?
Quadratic function.
A what? Somebody said something, I didn't hear you. X squared minus 8x plus 5 is what kind of a function?
Parabola.
Parabola is a graph. Parabola is not a function.
Quadratic equation.
It's a quadratic. It's a quadratic. What do you know about quadratics? Ms. Vardy?
It's continuous.
Yes, it's continuous. All quadratics are continuous. All polynomials are continuous. Okay? So x squared minus 8x plus 5 is continuous because it's a quadratic, and quadratic is a family of a polynomial. All polynomials are continuous. So that satisfies the first part of the graph. It is continuous. It is on a closed interval. Is this function referred to in a closed interval? Yes or no? Junior.
Yeah.
Is this function on the closed interval?
It is 2 and 6, no?
You asking me or you telling me?
No, it is. It's continuous on a closed interval 2 and 6.
Yes, the interval is given to you guys. It's right here.
It's in
It's
there.
given to you, 2, 6. Now the question, to answer the question, determine if Rolle's theorem can be applied. So we see 2 of them. Now we have to figure out what is f of a, and is that equal to f of b? So what is f of a? Well, it's the function. F of x is equal to x squared minus 8x plus 5. So f of 2 would be 2 squared minus 8 times 2 plus 5. So f of 2 is equal to 4 minus 16 plus 5. So f of 2 is equal to -7. Now, what is f of b? F of b, and b in this case is 6. This is going to be 6 squared minus 8 times 6 plus 5. So f of 6 is going to be equal to 36 minus 48 plus 5. So f of 6 is equal to -7. So therefore, f of 2 is equal to f of 6. Hence, f of a is equal to f of b. So yes, it is satisfied. And since it is continuous, it's differentiable at every single point. So yes, Rolle's theorem can be applied to the function. Do you observe what I did there, class? Hello?
Yeah.
Yes.
Hey, can we like speak up and be in class here today, please? Now, if it can be applied, I'm sorry, what was that?
I said you're kind of moving fast.
Okay,
Yeah, I was soaking it in myself, trying to understand it.
so basically, let's just recap what I'm doing, right? I'm trying to see if every condition on the theorem is satisfied. That's what I'm trying to do. So if I stick that condition in here, let's see. Right, I want to see if the condition here can be applied. So the first thing we do is f continuous on a closed interval, yes or no? So we go to the function and we look at the function here. Is this function continuous? And since it's a polynomial, all polynomials are continuous. And it is given, it tells you it's on a closed interval. The closed interval is 2, 6. So the first part of the theorem that I've highlighted there in green has been satisfied or is satisfied. We move on to the next part now. Let's look at the yellow part. Is it differentiable on AAB? Well, if it is continuous and there is no sharp point, it is differentiable. Polynomials are smooth curves, right? These are things you guys have to know. A polynomial is a smooth curve. There is no sharp point, such as the absolute value, like this one here. Polynomials are nice, smooth. It's like a roller coaster, right? They may have big drops, but they're smooth. There is no way a roller coaster can ride here. If it does, it's going to get stuck because it's a sharp point. So when you talk of a smooth curve, you have to think, is it possible if you put a roller coaster here, would it be able to travel? And obviously it can't travel in that V, right? Because on the V itself, it's going to get stuck between the V. One wheel will be here and the other wheel will be there. It's going to get stuck. Does that make sense, guys?
Yes, sir.
Right? So that's when we talk about a nice smooth curve. When you talk of a smooth curve, imagine in your mind, right? If you were on a roller coaster, would the roller coaster be able to travel from the left side to the right side of the curve? Okay? You can think of it as that. So where's my definition? So it is continuous because it's a polynomial. It is differentiable in an open interval, right? Because if it's differentiable, since polynomials are continuous, it is an open interval, so it's differentiable. Now we have to figure out this piece here, this piece. If f of a is equal to f of b, and we do that here now, we figure out f of a, is it equal to f of b? Okay? So we take the function and we plug in a here is 2 and b is 6. It's the end point of the closed interval, 2 and 6. And we plug them in and we saw that f of 2 is equal to -7 and f of 6 is also equal to -7. Therefore, f of a is equal to f of b. That's it. Are we good so far?
Yes.
Now, go back to the definition, and the definition, oh, I forget I pasted. The definition said if f of a is equal to f of b, then there is at least one c in the open interval such that f prime of c is equal to 0. So what you guys have to do now, you will have to now go and find this. So take the first derivative of the function. You have the function, class, f of x. So to find c, find f prime of x and then set it equal to 0. So please do that for me. Take f prime of x is quadratic, so everyone should know how to find the first derivative, okay? So f of x is equal to x squared minus 8x plus 5. Ms. Perez, what is f prime of x? Ms. Perez,
Yes.
what is f prime of x? Ms. Perez, why isn't your phone, your camera not on?
Well, I don't know if you saw my message, but I sent you an email and I sent you a message through the Zoom that my camera currently doesn't work. Did you not
Okay,
receive my email?
I don't know when you sent it, but it wasn't there at 6 o'clock this morning when I read email.
Oh, I sent it 30 minutes before class.
No, I don't check emails 30 minutes before class, miss. Please make sure by Thursday your camera is working, miss.
Yes, I'm working on getting it fixed.
Thank you. Can you tell me what's f prime of x, please?
It's 2x. Hold up, because I'm still writing it down. So it's 2x. Two x minus 8 and 5 would be 0, right?
Yes, the derivative of a constant is 0. So that's f prime of x.
Yeah.
Now, let f prime of x equal 0 and solve for x. So, Mr. Jonathan, what do you have if you do that?
Final answer?
What's that?
You want the final answer?
Well, tell me what to do.
Oh, I just plugged in, I got 2x minus 8 equals 0, and I just solved for x, and I got 4. So that would be C, right? C is 4. F of C is
C is
4.
4. Yes. C is equal to 4. Okay. Now, so here's a big question, right? Big question, because this is always overlooked. Okay. Is 4 within the closed interval? Or within, let's just say the interval. That's a big question. So what
Can I
was
answer?
what was the interval we had?
2 and 6, no? So it should be within the interval because it's a
Yes.
number in between, no?
So you want to make sure that anytime you guys solve for C, and sometime when you solve, guys, please pay attention. Sometimes when you solve, you're going to get more than one C value, okay? So you want to make sure that all the C values you obtain is within the interval. If it's not in the interval, then you have to get rid or ignore the C that is not within the interval. Does that make sense? So since this one is, it is in the, their f prime of C is 4, right? Any questions?
Would that mainly happen if you have to use the quadratic and do like,
No, it could happen for, I mean, it's possible. It's possible. Okay. And then also you want to make sure that at that point, the function is differentiable at 4. But we already satisfied that condition, right? We say that this highlighted function in green here, it is continuous. So if it's continuous, it's differentiable at every point, right? Because it's a nice smooth curve, the roller coaster thing I talked about. So let's look at another example. So given f of x is equal to 3 minus the absolute value of x minus 3, okay, on the closed interval let's say 0.6, and we want to determine whether Rolle's theorem can be applied to f of x on the interval. If it can, okay, if it can be applied, find the value or values of C in the open interval AB. So please try this one. It's very similar to what we've done before, right? Please try it. Please take a few minutes and try it, please. Mr. Wu, how are you making out? Wu, here today? Dilly Wu,
Yes.
are you finished?
No, not yet.
No. Ms. Rodriguez,
I'm here.
are you finished, miss?
No, not yet.
Okay. Is anyone finished?
I think I am, but I'm confused if I did the derivative right.
Who's talking?
Me, Jonathan.
Jonathan, okay. Miss Yang Yang, are you finished?
Yes.
Go ahead. What did you do?
F0 equal to 0 and F6 equal to 0 and they are equal, but F prime is doesn't exist, so it cannot apply.
Okay, so what Miss Yang Yang did, so let's reinsert again the definition here, guys. If you don't know, if you don't apply this or use this, you're not getting anywhere, okay? So let F be continuous. Here is what we want to do. We want to make sure that it is continuous, okay? Come on. Is it continuous on the closed interval? So here's the function. Here is the function. It's an absolute value function or absolute value function continuous? Yes or no?
Yes.
Yes, it is continuous. Is it on a closed interval? Yes or no?
Yes.
Yes. How do you know yes, Miss Yang Yang?
You just give us the close interval.
Yes, I give it to you. Life is sweet. Look, I give it to you. It's on a closed interval. I told you it's on a closed interval.
Yes.
You don't have to look for it. It's given. Now, go to the next part of the definition. And differentiable on AB. Differentiable on AB. Is that satisfied? Yes or no? Is the
No.
absolute value function differentiable at every single point? Yes or no?
No.
No. So you could stop right there. You can write in words, right, Miss Maciel?
Yes.
What would you write, Miss Maciel?
4 for that. I'm still not finished with it.
I don't think the problem is you're not finished. I think the problem is that you weren't paying attention to anything I was saying. Yeah,
No, I'm still not finished with it.
please pay attention, guys. So you can write out in words. You didn't have to do any math for this problem. You can just say that the function is continuous on the closed interval, but because it's an absolute value function, it is not differentiable. Now you have to be careful because there's only one point on this function that's not differentiable, right? And what point is that? If you look at the function, what is the point that's not differentiable? So if you look at the graph of this function, I hope you guys can graph this without a graphing calculator. The absolute value of x looks like this. Absolute value of x looks like this. This is the absolute value of x. But what does the absolute value of x minus 3 look like? X minus 3 would be looking like this, right? This is the absolute value of x minus 3. But you have 3 minus the absolute value of x minus 3. So now your graph would go up 3, 1, 2, 3, and then it's also inverted. So your graph is going to look like this. This here is 3 minus the absolute value of x minus 3, the red graph. These are all transformation of functions from pre-calculus. Okay. So what value of x is this function not differentiable on? What value of x is this function not differentiable on?
3.
3, yes, 3. What is the closed interval here? Your closed interval is
0 and 6.
0, 6. Is x equals 3 in the closed interval? Yes or no?
Yes.
What?
Yes.
Yes. So that means this function is not differentiable on the open interval 0, 6. Do you agree with that statement?
Can you explain why, just one more time? That
Why what?
why at x equals 3 it's not differentiable? Just for
Look, I
plain
have a
English.
sharp, it's not a smooth curve. You can only differentiate things with smooth curves. There's a peak there. Roller coaster can't go from one side to the next side. It's gonna get stuck there. Okay.
If that number was not in between 0 and 6, we would still continue with the problem.
Yes, you would continue. Well, then you would have to check what is f of A, what is f of B. Although, if you miss that and you find f of A, which is the same as f of interval was 0, you're gonna get 0. And f of B, which was f of 6, right? B was 6, yes. You will also get 0. So you may think that f of A is equal to f of B, and that will satisfy this part, but this part is not satisfied. The entire statement here has to be satisfied. 3 conditions. Well, 1, 2, 3, 4 condition. Function has to be continuous, must be in a closed interval, must be differentiable, and f of A must be equal to f of B. 4 things. If these 4 things are not checked, that's it. The theorem is flawed. We have a problem with the theorem. Well, we have a problem with the work that satisfies the theorem. Questions? So for this function,
I have a question.
yes.
So this problem basically only satisfies one part of Rolle's theorem, but not both parts.
But not all parts, correct.
Okay.
Okay, correct. It's just the same thing. I mean, if I ask Yang Yang, are you Dennis? Maybe you're both female, but does she have all characteristics of Dennis? No, she don't. Everything has to be satisfied. Does that make sense?
Yes.
Not just one piece, everything. There are at least 4 things you have to check, right? Here, has to be continuous, has to be in a closed interval, has to be differentiable on the open interval. And then if those 3, f of A have to be equal to f of B. Maybe this is going to be satisfied, maybe this is going to be satisfied, maybe this is going to be satisfied. And when you do this one here, maybe it's not going to be satisfied. So it all depends on the function. Okay, guys? It all depends on the function. So your answer for this question here is that the function is continuous. It is in a closed interval, but it's not differentiable on the open interval. Hence, Rolle's theorem is not satisfied. Any questions with that?
Professor,
Yes.
I'm really confused about this theorem. But
About
I think it's useless. Because like we can just use the f prime to find the the turning point, right? So why do we need use this one to like verify is there a point like f prime equal to 0?
Well, if you take the derivative of this, how do you take the derivative of this function to Yang Yang? You have to break it up into 2 parts. What's the derivative? If I tell you, so here's some scrap work, guys. If I tell you g of x is equal to the absolute value of x minus 3, and I ask you what is g prime of x, how do you find the derivative, folks?
Like separate 2 part.
Right, exactly. That's the only way you can do it. First, you have to say that g of x is x minus 3 for x greater than 0, and minus x plus 3. No, minus x minus 3, right? Or let's do it this way. We can say it's x minus 3, the positive, and minus x minus 3. Right? Those are the 2 parts. So this is for x greater than 3, and this is for x less than 3. Okay? So you have to differentiate each part. And that's the same thing you're going to have to do here if that's what you're asking me. Is that what you're asking me, Yang Yang? So sometimes the derivative is not going to be easily visible. So that's why I usually go through the first few tests. They're much more easy to see, in my opinion. They're easier to see. Okay. Any other questions before we now move on to the mean value theorem? So we now want to look at the mean value theorem.
What happens if you don't give us the interval?
If it's closed or open?
No, if we don't have it.
You have to.
Okay.
If it's not directly given to you, there has to be something that's sort of like hidden in the problem where it's telling you that it has an interval. Some interval has to be given or interpreted in the problem. Because we must have a closed interval.
Okay.
Okay. So you have seen this formula. I hope you can remember what is f of a minus f of b divided by b minus a. I hope you can remember this. Can anyone remember this?
fx plus delta x minus fx
Uh,
divided by delta x.
average rate of change, guys, f of b minus f of a. Right, and that's why we have the mean in the mean value theorem, because average is the mean. Okay. Remember in pre-calculus when we talk about average rate of change, we said it was f of b minus f of a divided by b minus a, wasn't it? Average rate of change. So let's look at an example here and see how we use this one in this case. Example. Okay. So determine whether the mean value theorem can be applied, okay, to f on the closed interval -1, 1, okay, and then if it can be find all value or values of c in the open interval. -1, 1, such that f prime of c is equal to f of b minus f of a over b minus a. And I'm going to give you f of x is equal to x cubed minus 2x. So please try that one for me. Take a few minutes and try that. Go through, similar to what we're doing, go through the definition and make sure you follow every single part. Okay. Here's the definition. There's a definition.
Professor, can you go down a little bit?
Down or up?
Down, because I can't see the equation you give.
Oh, I'm gonna go up. That's what you need to see?
Yes, thank you.
Uh-huh. Are we doing?
I got -1.
Okay. So let's
need-
check it.
Two.
Say what?
Just saying I got the same answer.
Okay, so let's see if f is continuous. So is this function continuous? X cubed minus 2x?
Yes.
How do you know?
Again.
Because it's a roller coaster.
No. The cubic.
Everyone know what a polynomial is?
Yes.
Let me stop this video first. F of A is equal to f of -1, which is equal to -1 cubed plus 2 times -1, which is equal to -1 minus 2. So f of -1 is equal to -3. Okay? Now what is f of B? F of B
It's -2, no +2.
Oh, okay, thank you. Okay, thank you. F of B and B in
Professor.
our
Professor,
Yeah.
shouldn't it be like +2?
F -1 should be 1.
Hold on.
FA.
You had it right. When you switch the signs, it just -1 plus 2 is negative, or is +1.
Yeah.
-+2.
Hold on, one second. What's the function I'm using?
Down in the box.
X
X
cubed minus
cubed.
2x.
-2.
Oh, I copied the function wrong. This was supposed to be a plus, that's why. That was supposed to be a plus. That's why I wrote a plus there. Sorry. Please make changes in your notes. This was supposed to be a plus 2x. So f of B will now be f of 1, right? Which is equal to 1 cubed now plus 2 times 1, which is equal to 1 plus 2, which is equal to 3. So f of 1 is 3. Okay?
Yeah.
Now the question is, what is f prime of C now? What is f prime of C? So remember, f prime of C is f of B minus f of A over B minus A, right?
Yes.
Right?
Yes.
So we have f of B already. F of B we know is 3. So we have 3 minus, we know f of A because we found that before. F of A is -3. So minus a -3 over 1, B was 1, right? B,
Yes.
if you go back to the problem, this is A and that's B, right? So it's 1 minus a -1. And that is equal to 3 plus 3 over 1 plus 1, which is equal to 6 over 2, which is equal to 3. So f prime of c is equal to 3. Okay. Now, what does this tells us? What does this tells us? Keep in mind, this tells us that the slope of the secant line, or the line, keep in mind that is a secant line, okay, that passes through the point -1, -3, and 1, 3 is 3. Do you agree with that statement?
Yes.
Okay. So how am I getting this? Well, if you look at this picture, okay, for those of you who don't quite understand what I just wrote there, okay, let's say we have the graph. Let's say here is -1. Let's say here is 1. The secant line is this line here, right? Let me see if I can do this. So m for this line is 3. That's what it's saying. Okay. Now f of x, which is this thing here, is x cubed plus 2x, right? That was what it was? Yes, x cubed plus 2x. What is f prime of x? Is Dennis?
Did you call me?
Yeah. What's f prime of x?
3x to the second power plus 2.
Yeah, cool. So we know, right? We said that f prime of x has to be equal to 3. Right? We know this. This is given from up here. F prime of c is 3. Therefore, if we set this equal to this, we can solve for x. So therefore, 3x squared plus 2 has to be equal to 3. And now solve for x. If you do this, you have 3x squared is equal to 1. X squared is equal to 1/3. So x is equal to plus or minus the square root of 1/3. Therefore, x is equal to plus or minus 1 over root 3. Right? So C, now be careful, guys. We get plus or minus here. What was the interval? Question.
-1, 1.
Is -1, 1. Okay. Now, this number here, it's smaller than 1, isn't it? Is it smaller than 1 or bigger than 1? Check it in your calculator, guys. What is 1 over the square root of 3?
Smaller than 1.
Smaller than 1. Okay. So, C equals the square root of 1/3, or C can be minus the square root of 1/3. Either one of them is correct. We have two C values. So the C value here is the square root plus or minus the square root of 1/3. Questions? So realistically, the intermediate value theorem uses, or sort of, we have to know the mean value theorem before we can use the intermediate value theorem. Or we have to know Rolle's theorem before we can even apply the mean value theorem. Okay. So these are just two theorems that sort of justify things. Okay.
Professor,
Yes.
I have a question for the last theorem. I mean the last one, the Rolle's
theorem?
Yeah, Rolle's theorem. Like if I give you the interval, but like 1 to 5, but f1 not equal to f5, but there actually there is a f prime equal to 0 is this, so
No, it has to be equal. F of A has to be equal to F of B.
yeah, but if the interval the question give to me is not equal, so
Well, the interval doesn't have to be. Look at this interval. Look at this interval here. I'm not sure if this is what you mean. This is 2 and this 6.
yeah,
The end point of the interval doesn't have to be equal. What you have to make sure is when you find F of A, is that equal to F of B? These things here have to be equal.
but like if I give you the interval is in the same function, but I give you the interval is 2 and 7, but the 6, you know, the f6 actually include in the f2 to 7, right?
No, the endpoint has to be, you have to use the endpoint. You can't use the middle or some point. If I'm telling you that the function has, so here is some follow-up. If you have a function, f of x is x squared plus 4, and I'm telling you the closed interval is -1 and 1. Okay? Right? First thing is, this doesn't have to be the same. This could have been a 5 and this could have been an 8. It doesn't matter. And what you have to test f of -1 and f of 1. You cannot choose values between. You have to check the end, which is called the left end, and you have to check the right end. Have to.
Okay, got you.
Any other questions, class? Any other questions?
I
Okay,
don't have any questions.
so we'll stop there for today. Okay, we'll stop there for today. And remember, on Thursday, okay, you guys will take your exam. The exam will be on WebAssign as usual. The last time you guys did WebAssign, right?
No,
No,
it's
that's
Blackboard.
the
Blackboard.
Okay, so I'll give you the exam on WebAssign, and then you will upload your work onto Blackboard. So you'll log into WebAssign, you will take your exam, you will do all the work on paper, and then when you finish, you scan it and you upload it to Blackboard. Okay.
I had a question about that.
When we do that,
How can you do it?
so
The
it
same way
like
you
on
did
web
exam one, you take your work and you upload it.
okay, now I'm saying like we're gonna have an under assignment exam, so we have to upload there, right?
Wait, slowly for me, what?
That's okay.